Today we're going to be looking at something called two-way tables. What I ask while I'm gone is that you please watch this video and pause it to take notes, so that way you have notes for your homework and for your quiz on Friday, because there will be a quiz, or part of the quiz questions will be on two-way tables. So we've been spending quite a little bit of time with looking at box and whisker plots and histograms as data that is quantitative, meaning using numbers. But this time I want to look at categorical data or qualitative data, data that uses categories. So what a two-way table is it's a table that uses two sets of data and compares the amount of people or things within them. So let's take a look at an example of a two-way table. This slide here, it tells you that it is an example of a two-way table that asks 80 seniors what kind of science class that they are taking. So the biggest thing to look at here in the two-way table is that you have two different variables. You have the gender on the left-hand side, whether they're male or female, and then across the top you have the science class that they say they're taking. So another key feature of the two-way table is the last row and the last column both say total. So in the very last row, last column, in the bottom right-hand corner box, it says 80. That should be the total of both the columns and the rows. So all the students who were asked were 80, so that means altogether there are 80 females and males together, and there are 80 students taking science class. So each way it should equal 80. So let's look at how we could fill these in. So if we're looking at the total column, we know that there are 80 total people that were asked about their science class. Well, we also know that 47 of those 80 students were female. So to find the number of males that there were total, I could take my total, 80, and I could subtract the 47 from it. So I'd have to borrow, that becomes a 7, and then I would have 3 left over here and 3 left over here. So that would mean then that I have 33 males in total. I could do the same thing for physics, which would mean that I would take the total 33 and subtract the number of females, 14, and I would end up with 19 males in physics. Now, if you look at the next two columns, biology and chemistry, we're missing 2 from each side. So let's look at particularly the box that says female and chemistry. So if we look at females in science, we know that there are 47 females altogether. So I know also that 18 of the females are in biology and 14 of the females are in physics. So I could take the 2 that I know, biology and physics, so I have 18 and 14, and I can add them together to see how many females we know that are already in science class. So 8 plus 4 gives me 12, carry the 1, and that gives me 3. So I know that I have 32 females altogether in chemistry. I'm sorry, not in chemistry, in biology or physics, but I want to find chemistry. So I can then take the total females that we have, which is 47, and I can subtract the 32 that we already know where they belong. So that gives me 15 left. So that means that there are 15 females in chemistry. So now I can do the total and the female in chemistry to find the males again. So 21 minus 15 gives me 6 males that are in chemistry. So then I can find out the number of total males and the number of, or total males in biology and the number of total students in biology altogether. So if I find the number of total students altogether, I could take the chemistry students, which is 21, and the physics students, which is 33, and I could add them together. So I'd get 4 here and 5 there, so I get 54. Then I could take my 80 students that I have altogether, take away the 54 where I already know they belong, so that has to borrow. That gives me 6 and 2. So that gives me that there are 26 students in biology altogether. So then I can take the 18 females away from the 26 total, and I get 8 altogether. So the key that you want to remember here with the two-way tables is what it says in bold at the top. It says in a two-way table, the sum of the column totals equal the sum of the row totals. So the way to check this is once you have them all filled in, you can add going across horizontally and then up and down vertically. And you should get the total that is in the bottom of each one or on the side of each one. So, for example, to make sure the females column is right, or row is right, I could add the 18 in biology, the 15 in chemistry, the 14 in physics, and I should come out with a total of 47 females. And then I should be able to do the same thing for the males and the same thing for the total. And then I should be able to do the same thing going vertically for each science class and the total column there as well. So every time the sum has to work, otherwise you have an error in one of your spots in your table. So now I want to switch to another two-way table, or at least part of a two-way table, and I want to look at this where it gives you a part of a two-way table where it talks about the number of people who prefer the type of pet and how many people said that. So it tells you that Jenna asked 40 kids at school what kind of pets they prefer, cats, dogs, or others, and then she has a table here. So I want to look at something called relative frequency. Basically, relative frequency takes into account the total or the whole of your group and then what part or what percentage of people want or like that particular thing. So if we're looking at this, it tells you that it can be represented in 3 different ways. Relative frequency is a fraction, a decimal, or a percent. So I want to look at how to convert between the two, or the 3. So if we're looking at dogs, for example, the relative frequency as a fraction, how many people like dogs? Well, 18 people said they like dogs, so I have 18 out of how many? The total people she asked was 40, so it's 18 out of 40. And then I need the same thing for cat, other, and total. So cats was 12 out of 40. Other is 10 out of 40. And then the total is 40 out of 40 because she asked everybody in her sample. So then you can also write the relative frequency as a decimal. So once you have it as a percent, you can divide, as it tells you in the red on the side, your numerator by your denominator, the top number by the bottom number, and it will give you a decimal. So without showing you all the long division at the moment, because you will and do have access to a calculator, if I divide 18 by 40, I should get 45 hundredths. So my decimal is 0.45 or 45 hundredths. If I divide 12 by 40, I get 3 tenths. If I divide 10 by 40, I get 25 hundredths. And then if I divide 40 by 40, I get 1 whole. Now that we all have that as a decimal, we can then look at turning it into a percent. So if I'm going to turn these into a percent, remember I have to take my decimal and I have to move them twice to the right. So if I take my decimal in 45 hundredths and move it twice to the right, I have 45%. And then twice to the right with 3 tenths, fill in the second empty space with a 0. That leaves me with 30%. And then the same thing with 25 hundredths. If I move it twice, that leaves me with 25%. And then if I move it twice from the 1, remember if there's not a decimal, it's a whole number, it starts at the back. So then if you have the decimal at the back of the 1, you move it over twice and you get 100%. Now, how you can check to know if you have this right is because you have to think about it as being part of the whole. And the key word there is of. Of, usually, not necessarily always, but most of the time, the word or the number that come after of is your whole or your denominator. So we're looking at this as part of a whole. So the way to check is if you're looking at your fractions, all of your fractions should add up to, in this case, 40 out of 40 because there were 40 total people that they asked. So your fraction needs to end up being able to be simplified to 1 whole. Then if we look at the decimal, it's the same concept. I need to be able to add, going horizontally, the decimals, and I should get 1 or 1 whole. And then the percents, if I'm asking everybody in my sample group and taking everybody's results, I should end up with 100%. Now, a word of the wise. These fractions were made nicely, meaning I purposely picked data that gave you relatively easy fractions, decimals, and percentages. Now, in real life, if you really were to conduct a survey and record the amount of pets, or not the amount, the preference of pets that people have, would your data come out as perfect as this? In likelihood, probably not. So because it's not necessarily going to come out like that, you would then have to look at it and say, okay, I'm going to end up at some point having to round some of my answers. So just like we talked about in class with the standard deviation, if you round, you just get further and further and further away from your actual real valid 100% correct answer. So by looking at this, you have to recognize the fact that you, when you add horizontal, might not be getting exactly 100%. You may come up with 99% and some odd decimal. That's okay, especially if you rounded. If you didn't round and you're not getting 100% or 1, then you have an issue. But as long as you're coming somewhere close and it's just a little bit off on the decimal portion of it, is most likely due to rounding. So now what I ask that you do after you've taken notes on this is that you work on your homework for two-way tables. And if you have any questions with the two-way tables or any of the other stuff that we've had looked at before, please, please, please come see me during advisory, as we have a quiz on Friday, and this is on the quiz, as well as tomorrow we're going to start a data analysis project, which you will need to know how to do all the stuff we've talked about already, including standard deviation and two-way tables. So if you have any questions, like I said, please come see me during advisory tomorrow.